Types of isomers. Today's topic, let's talk about the types of isomers with examples. Isomers are molecules that have the same molecular formula but different structures or arrangement of atoms. This difference in structures leads to distinct chemical and the physical properties. What are the types? Structural or constitutional isomers. Isomers differ in the connectivity of their atoms. In this type of isomers, the atoms are connected in different orders, resulting in different structures. Positional isomers. Positional isomers under constitutional isomers. They differ in the position of the functional groups attached to the carbon chain. For example, 1-butanol and 2-butanol. You can see the OH group is the functional groups in both. However, 1-butanol OH groups attached to first carbon and 2-butanol OH group attached to the second carbon. Functional group isomers differ in the type of functional groups. For example, ethanol and dimethyl ether. In both structures, the molecular formula is same, however the functional group is different. In ethanol, OH is the functional group, the alcohol group, and dimethyl ether group is the functional group, COC group. The next category of the isomers are stereoisomers. Stereoisomers have the same connectivity of atoms but differ in the spatial arrangement of atoms. Stereoisomers are further divided into the geometric isomers, we call cis-trans isomers. The cis-trans isomers differ in the relative positions of substituents around a double bond or a ring structure. In cis isomers, the substituents are on the same side, while in the trans isomer, they are on opposite sides. For example, trans-butene and cis-butene. You can see the substituent CH3 is in opposite directions in trans version, but in the cis-butene, CH3 groups are on the same side. Optical isomers or enantiomers is under stereoisomers. These are non-superimposable mirror images of each other, like our left and right hands. They have identical physical properties, except for the direction in which they rotate plane polarized light and their interactions with other chiral molecules. Example, D-lactic acid and L-lactic acid. They are mirror images of each other, but they are non-superimposable. The third category is conformational isomers. A conformational isomers, also known as conformers, are different spatial arrangement of a molecule that results from the rotation around a single bond, we call sigma bonds. These isomers are not different compounds, but rather different forms of the same molecule that can interconvert without breaking a bond. These are Newman projections of butanes. Newman projections, a common way to visualize conformational isomers. In this, butane has 4 conformations included on the slide: fully eclipsed, gauge, eclipsed, and anti, or we call staggered conformation. If we rotate CC bond in 60 degrees angle, so we can interconvert to each conformations. Butane has more complex conformational due to its longer chain. So it has anti-gauge and eclipse conformation. The anti-conformation, or we call staggered conformation, is the most stable because the 2 methyl groups are at the 180 degrees apart. In cyclohexanes, the chair conformation is the one most stable due to minimized steric strain and torsional strain. I hope now you will have the basic understanding about the types of isomers.